Hello, geometry students. If you're needing assistance with the Chapter 2 test, I'm going to go read through it, and I'll start from the beginning. Maybe you need to fast forward it or something to the end, but let's take a look at this. I'm actually looking at students, but we'll go with it here. What is the difference between inductive reasoning and deductive reasoning? One of these, I'm going to give you some choices here. One of these, you're taking facts and you're coming to a conclusion. So you take facts and come to a conclusion. We did that with law of syllogism and law of detachment with one of these, okay? And that would be either deductive and inductive. So you could, replay that, rewrite that, write that down and decide which one that is. The other one is you have a trend or a pattern and you're just trying to figure out the pattern and you're moving on with the pattern. And you're kind of generalizing, giving the pattern. So following a pattern would be one of them. So that would be either inductive or deductive. So, write that for one of them as a description. For number 2, what are the two parts of a conditional statement? And what are the 3 other statements related to the conditional statement? So you could use your letters. There's a couple letters here that you could use. Remember, you want to somewhere use the words conclusion, hypothesis in there. And I'll give you a clue for number 2. The other 3 conditional statements are in the instructions or the directions for number 9. Lists all of the other 3, okay? And you could use those letters to represent it too if you want, okay? For number 3, what are the 2 things needed in order to create a biconditional statement? So a couple of things, biconditional, you need, first of all, what kind of statement and, what does it need to be? And you should also be able to, read it in a different direction, and it should be true also. So, somehow in your own words, you want to put that down there. You could use the letters again if you want to. For number 4, a good definition should always be able to be written as what, okay? So good definition should always be able to be written as what? You might want to talk about the way you read it, forwards, backwards, whether or not it's true or false, something in there. You want to put something regarding that. For number 5, what are the 2 laws associated with deductive reasoning in this chapter? Guess what? Mr. Fry is so nice. He put that in the directions. They're listed there. The directions for number 12. Those 2 laws are listed right there. Okay, it's right on your test. The answers are on your test. Okay, and then what you're going to want to do for this one to explain it, one of those is this. If P is to Q and Q is to R, then P is to R. Okay, one of them is that. And then the other one is, if P is to Q, and if you take these apart, because they're attached right here, and if you take them apart, then, P would be true by itself, and Q would be true by itself. Okay, that's the other one. So you decide which one is which when you go to the directions of number 12, and you have the laws listed there. For number 6, list 2 properties of equality we used for algebraic proofs, and be sure to write what each property states. So you guys have a long list, and you could use the one that represents this, the law of this, the law of this, the law of this, the law of this, or property of this, property of this, property of this, property of this. You also have the distributive as an example, the substitution, abbreviating here, reflexive, the symmetric. You're able to use your notes, so this isn't nothing new. Transitive, and then describe them. So like, for instance, if you pick the addition one, you might want to say, well, if I add something to one side of the equation, I add it to the other side of the equation. Okay, and you could do that for all of these. These are the easiest ones here if you pick those. For number 7, skipping this, I'm just clarifying. Just look for the other two. I'll tell you you're dividing by the same number each time, so you're dividing by something. And then explain that. Okay, find the next two numbers. After you figure out how this is, what you're dividing by, get the next two numbers. And then explain what you did. Hey, I divided, each number by this or something like that. Okay. For number 8, the sum of any two consecutive prime numbers is also prime. I want you to see if this is true. I'm going to give you a list of prime numbers. Okay, 1, 2, 3, 5, 7, 11, 13. Okay. So consecutive means right next to each other. So like if I take these two, they're right next to each other. If I add them together, do I get a prime number? Let me take these two, 5 and 7. If I take these two, I add them together, do I get a prime number? Okay, it's up to you. Remember prime number, the only number that you can multiply to get to it is the number and the 1 and the number itself. So are those prime? So if not, then those are your examples. Your examples of why it's not true. For number 9, we have to write the conditional statement, so just add an if and then to this for your conditional. P is to Q. Okay, and then your converse. So remember your converse is just going to be it backwards. And one thing I got to tell you is I led some people in the wrong direction. I got my converse and inverse mixed up yesterday. So the converse is just going to be then the Q to the P. And then the inverse is the first not. So not P, not Q. And remember the contrapositive is not Q, not P. Okay, that's a Q there. So, this is my P, and this is my Q, okay? So conditional, you're just going to put if you are, or if a person is, or if somebody's this, then they are this, okay? That's your first, that's your conditional. And then then flip it. If they're this, then they're this. And then you start adding the nots. Go back to the conditional. If not this, then not this for inverse. Contra, go back to your converse. Contra and converse go together, but the contra is just not. So if not this, then not that. Okay, and you write those. For number 10, you have the conditional statement in the United States. If it is July 4th and it is Independence Day, you would write, first of all, whether that's true or false. And then what you're going to want to do is you're going to want to write the its converse. So in the United States, if it is this, then it is this. Okay, just flip your ifs and thens. So this is your P, this is your Q. So then if it's Q, then it is P. That's my Q. All right. And then, so write it, and if that's true, write it as a biconditional. So then you'll write in the United States, just get rid of your if and then and just have the if and only if right here. If and only if, okay? So in the United States, it is July 4th, if and only if, da-da-da-da, okay? All right, you will write that down. I'm giving you too much. Got to rein it in. Okay, I need you to determine whether the following definition is a good definition. If not, explain why. A compass is a geometric tool. Okay, you should be able to read that differently, and you should analyze that to see whether that's not a good definition and give your reason why it is a good definition or not. 11. 12. you are to use the law of detachment or the law of syllogism. So one or the other. I'm going to tell you, let's just forget about Shanti for a second here, and let's go with this. If you are studying botany, then you are studying biology. If you are studying biology, then you are studying science. What I would like you to do is then put this together with this. Create your new statement with those two circled items. And then what is that? Is that the law of detachment or the law of syllogism? Okay, so write that here and then write what law it is. Okay? Remember, if you're using P's and Q's, this would be P, this would be Q, and then this down here would be Q again, because it's the same thing, studying biology, and this is R. So actually, you're going, P is to Q, Q is to R, P is to R. Okay, so what is that? Law of detachment, law of syllogism, we talked about that earlier. And then for this one, you have to eventually get to the point where you're proving X equals V. So this is a given. So you could write that on the first line and just write given. This is a given. Write that on the second line. It's a given. This is a given. That's the third. Write it there. That's a given. Then you're going to do a few things. You could do some substitution. You could do some symmetric property. You could use some transitive property in order to get the last three to get where X equals V. Use your notes. Hopefully this helps you guys, and good luck with this test.